Alright, problem 48. A ball on a string is swinging from the ceiling as shown in the figure below. Let D represent the distance that the ball is from the wall at time t. Assume that D varies sinusoidally with time. When t equals 0 seconds, the ball is farthest from the wall, D equals 160 centimeters. When t equals 3 seconds, the ball is farthest from the wall, D equals 20 centimeters. When t equals 6 seconds, the ball is farthest from the wall, D equals 160 centimeters. So part A, they want us to sketch a graph of D as a function of time. Okay. So if you plot the points that they gave us, t equals 0, it's 160 centimeters, so you put a point there. At t equals 3, it is at 20 centimeters, so you put a point here. And at t equals 6, it's back to 160 centimeters. Okay? Well, it takes basically 3 seconds to go from the low point back to a high point, so it should take another 3 seconds to reach another low point. So at 9, we're back to 20. And at 12, we're back to a high point of 160. Now you can sketch the graph. The graph should be labeled in the proper increments. Remember, this is distance from the wall. This is time. Okay? So we sketched a graph. After we sketch the graph, we should figure out what the amplitude is. So the amplitude is equal to the absolute value of high minus low, 160 minus 20, divided by 2, which is equal to 70. So the amplitude is 70. To figure out B, I noticed that the period, to go from high point to high point, is 6 seconds. So the period is 6 seconds. If you remember, B is equal to 2 pi over P, period. So 2 pi over 6 is equal to pi over 3. C represents the phase shift. Since we start at a high point, I'm going to use a cosine equation, so C is going to be equal to 0. And if you remember D is high, the maximum plus the minimum divided by 2, so D is 90. So to write the equation, part B, write a trigonometric function for D as a function of time. D equals 70 cosine pi over 3t plus 90. So now it asks us, what is the distance of the ball from the wall at t equals 5 seconds? Well, this is where we need our calculator. So if you go to y equals and you type in 70 cosine pi divided by 3 x, in this case x is the same as t as our variable, close parentheses, plus 90, and then you go to your, make sure we are in radian mode. We are. And now we have to go to second calc. The value, what's the value of the function? When x is equal to 5. Hit enter, you get 125 centimeters. Then it asks you, what is the value of t the first time the ball is 40 centimeters from the wall? So this is where you go to your y equals, and in y2 we're going to put 40. When is it 40 from the wall? Now let's go to our window real quick. Let's graph this. So 0 to 30, and we know that, I'll make my scale 2. We know the minimum is 20, so I'll just leave it at 0. I know the maximum is 160, so we'll make it 200. Make our scale 20. And if we graph it, there's our graph. And they want to know the first time that it's, so the first time would be represented by this point right here, right, which is the intersection of our graph and y equals 40. So second calc, number 5 is intersect, and you want to move your cursor close to the intersection. You hit enter, 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 and it gives us an answer, which is 2.260 seconds.